Okay, so for this video, we are going to cover the definite integral. All right, and then including simple cases of improper integral. The part improper integrals, we will discuss it at the end of this chapter. All right, so for this part, we are only going to focus on definite integrals only. And after that, after we learn how to use definite integral, how to do the definite integration, then we are going to learn how to find the area, okay, under a curve, and also volume. All right, so you need to know that actually integration can be applied in finding out the area and volume for some certain curve and some certain shapes and so on. Right? Okay, so let's start with the definite integral first. Okay, so I think you should know about it. If let's say you want to look at the very standard definition for definite integral, then this is what we have. They're talking about continuous at every point in this interval, and if let's say you are having any antiderivative of f on this interval, then when you do the integration, it will be something like this. Okay, this one all is not important, all right? It is a bit beyond your syllabus already, like beyond your understanding already, so it's okay. But you will learn this in uni level, all right? If say you are still taking maths paper, right? Okay, so what I want you to know is this one. We are looking at the value for A and B. So the value of A and B, we call them as boundary values or limit of integration. Okay, so what we say is B is the upper limit and also A is the lower limit. So this is something that you should know. It is quite basic, all right, but you should roughly know the name of B and A. All right, so the properties of definite integral. Okay, for those who learn integration before, I think this one shouldn't be a problem for you. All right. Okay, so maybe we can try to discuss a few simple examples first. Maybe I show you one simple example. Okay, so when you're having the limits for integration, let's say I'm having limit 2 to 4, and then maybe I'm having something like 4x power half, and I want to do the integration with the limit. Okay, so again, 4 is a constant, so I just copy it, and then I want to integrate x power half. So x power half is plus 1 become 3/2, and then you divide it by 3/2 again, right? Okay, so for the integration with limit, you are not going to have any more plus c at the end of the integration. There's no more plus c, you can see, right? No more plus c. And then what you need to do is you have to put a square bracket after your integration. Then you need to substitute the value. You put in the value 0 and 4, the limit 0 and 4 first. Again, for me, before I substitute the value into the x, I will prefer to simplify all these. The divided 3/2 in my solution. I think it's very, very, how to say, I don't like that. Okay, I like it to be simple, so I will try to simplify first. So you take 4 divided by 3/2, you should be able to get 8/3. Then I will have x power 3/2 in the bracket. Okay, so I prefer this method. That means usually for my practice, I will always take out all the constant first before I substitute the value in. Okay, so this, when you look at it, you might think that if I don't want to simplify, also can I can simplify it at last, right? Okay, but somehow in some of the question in A2 level, if you notice, if I do it like this, my steps to simplify it to the answer, it will become much more easier. All right, so if let's say you can try to get used to this habit and habit means you can choose not to. All right, but for me, I think it is a good way for you to do it. Okay, all right. So for me, I will take out all the constant first, then I just left all the x inside if can. Then I will substitute the value. So first substitute 4 into the equation, into the x. So square root 4 is a 2, 2 power 3, you get an 8. And then minus, so before you substitute the second value, it's always minus between the first and second value. Minus, substitute 0 in, you get a 0. Alright, so therefore you're having 64/3 as your final answer. Okay, so this is what we have as a definite integral. Alright, so you plus c after integration for the definite integral, and then your final answer is the value, not an equation anymore. Alright, so that's the difference between the indefinite integral and also the definite integral. Right? Okay, so I believe that this one should be no problem for you. And after that, there are some basic rules or properties of definite integral that you should know. Okay, I think there are a few which is quite useful one. The first one and the second one. When you have two limits are the same, you will always get your integration with these two same limit equals to 0. Right? And then part B, I think is very important. You need to know. If you integrate from A to B, the answer will be the same as you integrate from B to A, but with a negative in front. Alright, then the rest I think is okay lah. Just a normal rules that you should know. Okay, but B I think is quite important. You should know about it. Alright, okay, so this part generally is a very simple revision part for you only to test whether you still remember it or not. Okay, so example 6 is a very simple example to test your understanding. Alright, so again, I will just give you the answer and you try out on your own. Okay, so example A, part A is 14, part B is 4, C is 24, D is 10, E is this one. Okay, they didn't give us the limit, but we still didn't give us the value of limit, but we still substitute the letter that they give us. Alright, and then for part F is this. Alright, so I think this one you can take less than 1 minute to complete it. Right, so just double check the answer and see whether is it correct or not. Okay, so in our notes here, I think in this part, they said E and F are known as improper integral. So please cancel off this part. This is not improper integral actually. The improper integral will be discussed at the end of this chapter. Alright. Okay, any problems so far? Right, so if no problem, then we will proceed further. Okay, so we talk about the area. Okay, so how can we use the integration technique to find the area of a region bounded by a curve, the x-axis, and also the line? Okay, so first you need to know that when we want to find out the area using integration, we actually find out the area under the graph. Area under the graph. Under the curve. Okay, so as the example, if let's say I'm having a curve like this. Okay, so where's the area under? Do you know where it's under or not? This part is under, right? The curve. This one is above the curve, right? Okay, so under the curve, area under this, something like this. Okay, so this is what you call as area under the curve. Okay, so when you want to find this kind of area, you can use integration to find out. So as another example, maybe for the first part of my graph, it is something like this. Okay, so this is one equation now, y equals to maybe 3x, let's say. Okay, and then where is the area under the curve for this graph? For this curve or this equation, it is a triangle. Okay, and then maybe the second part of this curve, it is another curve given. Alright. Okay, so again, this one, the area under the curve will be this. So when you want to find the area under the curve for two different equations, integrate the equation separately. Alright, so it will be good if let's say in the exam you have the figure of the question, right? Like which area they want you to find and so on. At least you can visualize it in a clearer way. Alright. Okay, so let us start with the details. Okay, so when they want you to find the area under the curve, alright, we are having two types. The first one is dx, integrate something to dx. Another one is integrate something to dy. Actually, I will tell my students a small shortcut. If you want to use dx, then you look at the figure that you have. If let's say your area is mainly covered by x-axis, then you use the integration for dx will be generally easier. Okay, but of course, this is generally not guaranteed all the question you can solve it very easily like this. Okay, but generally you can apply these small details here. Understand or not? So if let's say your area mainly is covered by or attached with the y-axis, then it will be easier if we use the integration for dy. Okay, but got exceptional case one. All right, not all the cases are like that, but generally it's like this. Okay, and then when you are when you already decide to use dx to find out your area already, the integration for dx, then the limit is the limit of x. Okay, the value of x. If let's say dy, then the value will be y here. Okay, so what is the value here? You have to see where your area start at value, okay, and where your area end. Okay, so as an example, if let's say you're having a curve like this, okay, so this is the point where your area start, then this is the point where your area end. Therefore, these two values will be the limit of your graph. Okay. Right. So once you know how to write the formula correctly, okay, so what you want to integrate, you want to integrate the fx. This is y. Okay, so y equals to fx. Must substitute the fx into the formula, and then do the integration. Then you can get the area that you want. All right. So this is a very general idea on how you use integration to get the area. Right. Okay. So let's start with the first part here. Okay. So the equation of the curve is this one. And then they want you to find the area enclosed by the curve, the x-axis, the y-axis, and the line x equals to 1. Okay, so for this question, how can I actually start to answer it? Okay, so first, actually what you need to do is like you need to know roughly how to sketch this graph. Okay, so the basic graph of y equals to square root x is this one. Okay, then now you're having y equals to square root 5x plus 4. So you can use the concept of transformation that we learned before. Okay, or if you're lazy, then you just use a shortcut. So x equals to 0, that means x equals to negative 4 over 5. You let 5x plus 4 equals to 0, then you get a value x equals to negative 4 over 5. That means you are moving the whole graph negative 4 over 5 unit. Negative means to the left. Alright, so this is negative 4 over 5. And then the curve of square root is like this. So your graph will look something like this. Right, sorry, my curve is not nice. So draw it better. Okay, alright, so if you need to apply all this that you learned before to sketch it out and help you to help you and see the area that you want. Okay, then now find the area enclosed by the curve. So this is a curve of the x-axis. So x-axis means this one. You need to mention, right? Y-axis means this one. And also the line x equals to 1. So maybe you need to draw a line here. This is x equals to 1. Okay? Alright, so just now, again, what they say, x-axis, y-axis, x equals to 1, and also bounded by the curve. So you can see that this is the area that fulfill what they want in the question. Okay, so this is the area that you want to find out. Alright, so okay, so how to find out the area here? Okay, so for this equation, from this figure, I can see that okay area attached to both sides. Okay, but for me, I think it's easier for us to use the dx. So you integrate something with dx. So you have to put in the value where your area starts, this value. So what's this value? 0. Where your area end? Here. So what's the value for x? 1. What is the equation for the curve? So it is square root 5x plus 4. Okay. Then after that, once you write out the formula correctly, then you can start doing the integration. Okay, so what do I have for the integration? So again, I change it become 5x plus 4 power half first. Alright, then after that, what should I have? Power plus 1 divided by new power. Do the differentiation for this bracket inside the bracket, so you get a 5. Alright, and then the whole thing, I want to put in the limit 1 and 0. Okay, so again, this fraction for me, it looks like a bit complicated. So what I prefer to do is that I will try to take out all the constant first. If I simplify, I'll have 2 over 15, and then it will become the bracket 5x plus 4 power 3 over 2, and then 1 and 0. Okay, all right. Then now you start to substitute the value in. Okay, 1 substitute in, you get a 5. 5 plus 4 is a 9. Square root 9 is a 3. 3 power 3, you get 27. Then minus, then now you put in a 0. So 4 power 3 over 2 is a power 3. Then you get an 8. All right, then eventually you try to simplify it. Hopefully you can get 38 over 15. Okay, or if you want, you can keep it in 3 significant figure. So I will keep it in the fraction. Okay, so to me, when they want you to find the area of under a curve, the very important part is, I think figure will be very useful. In A-level exam, I think most of the question, a lot of questions, they will actually give you the figure, right, in the question. But if let's say they didn't, if can, you try to draw it out if can, right? If not, then by imagination only, because when you draw the graph, they won't give you any extra on this. Okay, then after that, this is important, and then after that, this is also very important. You need to know how to write out the formula correctly. Okay, if you write it out wrongly, definitely the whole thing is wrong. So to me, I think you need to understand how you write out this one correctly. Okay, all right, so this is what you have for example 7. Okay, then we continue to example 8. Okay, so example 8, they want you to find the area of the shaded region. Please take note that this example, actually, I only take out part 2 from the original question. So maybe some information in the figure, you are not going to use it. All right, so don't get confused of that. Okay, but no matter how, they want you to find the area for this one. I think it's very, very similar to what we did just now in example 7. Okay, so again, you should know what I want you to do already. Complete the example yourself, and the answer for this area should be 28 over 3. Okay, so please try and see whether you can get this answer or not. So again, if you cannot get an answer or you get stuck, please message me and let me know. All right. Okay, then we proceed further. All right, so now sometimes you will see that when you are having a graph, you are having negative area. Not to say negative area, you will see that if, let's say, you integrate the area in the graph, which is below the x-axis one, you will get a negative value. All right, so we actually don't want this negative area in our calculation. So usually what we need to do is, after you get this area, you need to change it become positive, or you need to change it become the what? Change it become positive. All right, I think I need to stop here for a while to charge my laptop. Okay, so wait for a few, maybe give me 1 minute. All right, I'll come back very soon. Okay, so we can continue from here. Right, so, okay, where did I? Okay, again, so that means when you are having a negative area on the graph, area below the x-axis on the graph, when you do the integration, you'll get a negative value. All right, so for all these negative value, in area, we don't have a negative area. So you have to change it become positive, and then you only add them together with the other area. All right, so again, you have to change this one become positive first, then only you add with other area, which is the positive one. Okay, right. So if you look at the area here, you'll see that originally it is integrate from A to B lah. Okay, so from A, this is A, right? And then to B, this is B. So this original area is already positive, no problem. But when you integrate from B to C, this is a negative one. You'll get a negative value. So either you can put a modulus, that means you change it to become positive straight away, then only you add them together, or you can integrate it in a reverse limit. That means you integrate it from C to B. That means originally it's negative, you change it to become positive already. Alright, okay, so this is what we have for the negative area. Okay, then we can have a look for example 9. Okay, so example 9 is one of the example that you can see. It's from past year, October, November 2006. I don't know how old are you that time. 3-4 years old, is it? Okay, then let us start. This is the figure that already give us. So somehow you see that A-level question sometimes is still not too bad. They at least they'll give you some figure here, which is very useful. Okay, so they give you this curve. Okay, so they tell you also cross the x-axis at the point 0, 0, 1, 0, and 2, 0. So I think you should be able to know this one is a 0 lah. Then what is this one? This one is a 1, and then this is a 2. Okay, alright. Then after that, show by integration that the area of the shaded region R is the same as the area of the shaded region R2. Okay, so now we want you to find out the region for R1, shaded area for R1 and R2. So maybe I can find it out separately. R1 is the integration from 0 until 1. And then the equation that you have is x minus 1, x minus 2 dx. Okay, so can you integrate that straight away like this? Cannot. Alright, because they are multiplied. Something multiplies something multiplies something. Cannot. So you have to expand them, become addition formula, become addition function. Okay, so maybe expand it first. I'm having this as x squared minus 3x plus 2. Alright, then after that, I multiply it again. Okay, then only you start the integration part. Okay, so this integration part, the step is important because in the exam they might give you 3 or 2 marks for this particular step, the integration step. Alright, so please make sure you write it out. Maybe some of you feel very lazy or what, but you have to write it out. Okay, then after that you substitute the value 1 into it, and you have 1 over 4 minus 1 plus 1. Then 0 substitute, everything becomes 0 lah. So I just ignore it. Therefore, I can have 1 over 4. Alright. Okay. Then how about the R2? Okay, so if I want to find R2, it's the same thing. You need to integrate from 1 to 2. Okay, and then you're having x power 3. No need to expand it again. You just copy the expansion that you get from previous part. Alright. Okay, then because I know from this figure, the area here is below the x-axis. Therefore, I should know that after I do this integration, I will get a negative value. Therefore, in your steps, you can either put the modulus here if you want. If you don't want, then at the final step, you straight away change it become positive also cannot. It is understood because area must be positive. Alright, so it won't penalize marks for that. Okay? Right. So again, you will have x power 4 over 4 minus x power 3 plus x power 2, and then we put in 2 and 1. Okay, so I won't show you the detail of the steps anymore. If let's say you didn't do any careless mistake, you will get 1 over 4, and then after that, I will just put it as 1 over 4 for the area. Alright, then after that, don't forget to make a simple conclusion. So R1, area R1 is equals to area R2. That's it. Alright, so this question itself is not very hard. I just want you to make sure that you show correctly. Right, okay? Okay, then now we proceed further. The next example, I want you to try out on your own, but because this example, they didn't give you any figure. So maybe I can guide you how to sketch a figure first. Then after that, you use the figure to get the answer. All right, so they want you to sketch the area bounded by the curve. Y equals to x squared minus 1. Okay, so y equals to x squared minus 1. The original graph comes from x squared. So what's the x squared? It is a U shape. And then after that, when you want to transform it to x squared minus 1, what happens? You actually move the graph 1 unit down, right? So that means this point now is become a 1. So by using some small, a little bit of maths knowledge, you should be able to know that this is -1, this is positive 1. Okay, all right. So I'm going to sketch the graph here. Okay, so your graph might look something like this. Okay or not? All right. So this is 1, -1. This is 1. Okay, so if you read the question, this curve, the x-axis and the line x equals to -1. So this is the x equals to -1 and also x equals to 3. Where's the x equals to 3? Maybe it is somewhere here. All right. Okay. So again, if you look at it, what do you want? Okay. So what do I have is this one. Okay. This is the area that I want. And also this part. Okay, so you'll see that actually for the area that they want you to find out consists of two different parts. The first one is below the x-axis, and the second part is above the x-axis. Therefore, when you want to get the area, you need to do it in a more careful way. All right, so I'm not going to tell you how to do it again. If you can answer it correctly, you should be able to get 8 units for the area. All right. Okay, so this is how we use all the definite integration to get the area. But area, there are a lot of different subtopics. So maybe for this video, I will stop it at here. And then for the next video, we need to find the area again, but maybe we focus more on integration through y-axis one. That means the dy one. All right. Okay, so we discuss more in the next video.